Hello and welcome in today's video. In today's video, we are going to look at a method of computation of the determinant of a 3 by 3 matrix. This method, we call it the Sarrus Rule. It is a special shortcut method to compute the determinant of a 3 by 3 matrix. But we are not interested in computing the determinant using what we call the Laplace expansion or what we call the cofactor expansion. So for example, if you are given this 3 by 3 matrix with the entries A1 all the way to A3, the it is shown on the board. So what are some of the steps in computation of this determinant using the Sarrus rule? Step number 1, it is you need to pick the first column and the second column and write them again to the right of this particular matrix A. That's why we are saying that in the first step we write the first two columns again to the right of the matrix A. So once you do that, this is what you obtain. You obtain this matrix that is given below, and clearly you can see that you've written the first and the second column to the right hand side of this particular matrix A. So in this case, we form a larger matrix, which is this particular case a 3 by 5 matrix, because the number of rows equals 3 and the number of columns will be equal to 5 from the count. So what is the step number 2? Step number 2, it is we add the products of the 3 downright diagonals. By downright diagonals, we mean this. If you draw this particular line, let me use a different color. If you draw this line, this is an example of a downright diagonal, and there are 3. So meaning that this diagonal, diagonal will be having 3 entries, that is A11, A12, A13 or A33. The second one, it is this one, that is A12, A23, A31. The third one is this one, that is A13, A21, A32. So that in this case we define the products P1, product P2, and the third product, which is P3, as follows. That is P1 will be equal to this product here, which is A1 times A11 times A22 times A23, which is exactly what is being given there. The second product, which is P2, it is this A11 times A23 times A31, which is exactly what is given here. And the third product, it is this times this times this, which is A13 times A21 times A32. That is what is given here. So step number 3, we subtract the products of the 3 down left diagonals. So by down left diagonal, we mean these diagonals here. And the first one would be this diagonal here. You can see it is having 3 components or 3 entries, 1, 2, 3. The second one is this one here. You can see it is having the 3 entries, 1, 2, 3. So that's why we are calling it the down left diagonal. The third one is this one here. You can see it is having the entries 1, 2, 3. So what happens here, we need to define these values, that is N1, N2 and N3, as follows. So for N1, it will be this product, this times this times this, which is A31 multiplied by A22 multiplied by A13. You can start with A13 multiplied by A12 or A22 multiplied by A31. That is our N1. And you can see it is as follows there. So N2, it will be A11 times A23 times A32. And that is what exactly it is here. And N3, it is A12 multiplied by A21 multiplied by A33. That is what we have exactly here. So now with these products, the next it is we compute the determinant. Now the determinant of A, it will be given by the product P1 plus P2 plus P3 Then you minus these products n1 or n1 plus n3 plus n2. So as you do this, you'll be able to get the determinant of this particular matrix. Let us look at an example on the cell, that is the computation of the determinant of a 3 by 3 using the Sarrus rule. In this case, we are told to find the determinant of the matrix A, which is having these entries here. So what will be the solution here? So step number 1, it is we reconstruct this matrix A by just repeating column 1 and column 2 again in this particular matrix A. So our matrix A is having the entries 1, 2, 3, 4, 5, 6, 7, 8, 9. So again we write these columns 1 and 2 to the right of this matrix. This would be 1, 4, 7, and the second column is 2, 5, 8. Then from there we construct our values of P1, P2 and P3, and also N1, N2 and N3. So for P1, it will be given as follows. That is the product of those entries. We can be able to say that our P1, it is equal to 1 times 5 times 9, which is equals to 45. Our P2, it will be this diagonal here. So in this case you multiply 2 times 6 times 7. Our P3, it will be this diagonal here, which will be equal to 3 times 4 times 8. So the product P2, it will be 2 times 6 times 7, which is equals to 84. P3, it will be 3 times 4 times 8, which is equals 96. Next, we compute the values of N1, N2 and N3. So for N1, it will be the product of these diagonal elements. So the first diagonal is that one, and this will be equal to 7 times 5 times 3, which is equals to, next it is N2, which is equals to, this will be the second diagonal, which will be equal to 1 times 6 times 8. The third one is N3, which will be that diagonal, and this will be equal to 2 times 4 times 9. So the values of N1, in this case you need to multiply 7 times 5 times 3, which is giving us 105. The value of N2, it is 1 times 6 times 8, which is giving us 48. And lastly, the value of N3, it is equals to 2 times 4 times 9, which is equals 72. So therefore, the determinant, according to Sarrus rule, it will be equal to the sum of these products P1, P2 and P3 minus the sum of the products N1, N2 and N3. So should you sum this, this will be 45 plus 84 plus 96. You minus the sum of this product, which is 105 plus 48 plus 72. And simplifying this gives us 225. And this gives us 225. So 225 minus 225, it is equal 0. So next we compute the determinant of this 3 by 3 matrix B with the entries as shown on the board. So the first step, it is we write again the columns 1 and 2 of matrix B to the right hand side of this matrix B. You realize that these will be as follows here. So once you do that, this is your matrix B. So this is your column 1, this is your column 2. That is, you've written it again to the right hand side of this particular matrix B. So then we construct the values of P1, P2 and P3. So P1, it will be the product of this diagonal from here to here, which is having the entries 2, 4, 6. So should you multiply 2 times 4 times 6, you get 48. The second diagonal, which is P2, will give us the second product P2. It will be this one from here to here. So in this case, you multiply negative 1 times 1 times 5. And this is supposed to give us negative 5. The third one, which is the third diagonal, it is as follows there. So in this case, it means that we'll be multiplying the values 3 times 0 times negative 2, which is going to give us 0. So next, it is a construction of these values, n1, n2, and n3. So n1, it will be now this diagonal. That is the left down diagonal. So in this case, you multiply 3 times 4 times 5. This is going to give us 6 as shown on the table there, on the board there. Next, it is now n2, which is now this diagonal here. So meaning that we'll be multiplying the values 2 times 1 times negative 2, which is going to give us negative 4. And lastly, it is third diagonal. That is the third down left diagonal. So meaning that we'll be multiplying the values negative 1 times 0 times 6. So therefore, our determinant of the matrix B will be given as the sum of this product minus the sum of these products. So already you have what is your P1, P2, P3. You have what is your N1, N2, and N3. So meaning that this will be the same as what? This will be equal to 48 plus negative 5 plus 0. You minus is supposed to be minus N1 plus N2 plus N3, which is supposed to be 60 minus 4 plus 0. Supposed to be a plus 0 here. That is the value of N3. It is supposed to be 43 minus 56, which is going to give us negative 13.